Okay, so now let's continue with 3.4. After going over, the factor theorem, the remainder theorem, we're going to apply those to find all zeros of polynomial functions. So section 3.4, how do we find zeros of polynomial functions? So basically, we are looking for finding all these x-intercepts of the graph, okay? Whether they're rational, irrational, and so on. Because now we can find where the graph starts, it ends. We can find the y-intercepts. So how do we know what graph crosses of a polynomial function crosses the x-axis? Let's start with an example like I have in the notes on page 18, section 3.4. So if I have f of x equals x minus 2 times x plus 2 times minus 3. To find the zeros of f, so we write x minus 2 times x plus 2 excuse me, times x minus 3 equals 0. By setting each factor equals 0, we get x equal 2, x equal negative 2. Okay, now if we work this out, if you multiply it out, x minus 2 times x plus 2 is actually the difference of two squares, x squared minus 4. And then if you FOIL that, you get x cubed minus 3x squared minus 4x plus 12. If you look at the 12 and the 1, 12 over 1 is 12. If you look at the 2, the negative 2, and they're all factors of 12. They all divide 12 evenly. That's no coincidence, okay? That's exactly what we're going to talk about next. It's about the rational zero theorem. The rational zero theorem. This theorem will tell us where to look for rational zeros. It gives us the possible rational zeros. It doesn't give me the exact rational zeros, but if I'm looking for zeros or x-intercepts that are rational numbers, I will look at that part, okay? So what is that part? So this, let me write it down, gives the possible, and I want to underline that, possible rational zeros of a polynomial function. Okay, and what is that? So if we have a polynomial, if the polynomial function f of x equals, so I'm going to write the general formula, don't get confused with that, an xn plus an minus 1 xn minus 1. So the degree is n, and we're going down one exponent at a time, all the way to get a2x squared, a1x, which is the quadratic, then linear, then the constant. Okay, so if we have a polynomial function of degree n that has integer coefficients, so the a's are integers, okay, no fraction, no square roots, then every rational zero of f is of the form, it's rational, so it's a fraction, p over q. What is p and what is q? Where p is a factor, remember what we saw of the constant term? Remember what we saw? The 2, the negative 2, and the 3, they're factors of 12. 12 is p, and 1 is q. So when we do p over q, it's 12 over 1, and that's why these zeros are factors of 12, okay? So p is a factor of the constant term, and q is a factor of the leading term. of the leading coefficient. So this is the constant, the term that has no x, and this is the leading coefficient. And this tells me these are actually going to be zeros. They're possible rationals. So if I'm looking for a rational zero, where do I look? I look for these values, okay? The factors of P over Q. The factors of P over Q. Okay, so here's an example. Find all possible rational zeros of f of x equals 2x cubed plus 3x squared plus 3. So we're looking for P and Q. P is a factor of 3, so what are the factors of 3? 1 and 3. And Q is a factor of 2, it's just 1 and 2. So P over Q, we divide every P by 2, so 1 over 1, 3 over 1, 1 over 2, 3 over 2. And then it could be positive or negative, okay? So these are the possible rational zeros, possible rational zeros. So if I want to look for zeros, this is where I look for rational zeros. The irrational, it's not part of that. The complex zeros are not part of that. Now, how do we find the exact rational zeros? So this is just possible. Now we want to get the exact values. So finding the exact rational zeros. What I'm going to do, there's steps, and I have a handout in your notes. Okay, I have a handout in your notes. So as I'm doing this, I'm going to do problem number 24. Find all, so they're asking not just for rational, real meaning rational and irrational, okay? It's okay. For all real zeros of P of x equals x cubed minus 4x squared minus 11x plus 30. So if you look at the handout, that's part of your notes. It's included in the notes there. Find the exact rational zeros and then all real zeros. List all possible rational zeros. So the possible rational zeros, P over Q. P is a factor of 30. There's a lot. 1, 2, 3, 5, 10. That's a lot, which is no good. Okay. And then Q is a factor of 1, which is 1. So P over Q, it's all these divided by 1 plus or minus. So there's a lot to check. So that's no good. But we want to narrow that down since we're allowed to use technology. So we're going to plot the graph and using your grapher to narrow down your choices of zeros. So if you look at the graph by graphing it, so x to the power 3 minus 4x squared minus 11x plus 30, and then graph it. So it looks like what I see from there, 2 and negative 3 are zeros. How do we confirm that? We go to second table. Is 2 a 0? If we plug in a 2, is the y value 0? Yeah. And negative 3 is a 0. It looks like 2 and negative 3. Okay, good. So we know that 2 of them are, they have to be part of this. They are 2 and 3. Okay, so what's the next step? Use synthetic division to confirm the 0 from step 2. And note the quotient. We're not just going to use synthetic to confirm the 0. We already know they're zeros, but we're going to actually break it down. And let me show you the trick here. So synthetic division. We make sure that this is in descending order and no missing terms. If there's any missing term, put a 0 for that. So 1 is the coefficient of x cubed, negative 4 is the coefficient of x squared, negative 11 is the coefficient of x, and 30. We said negative 2 and 3, so we're going to try negative 2 first, divide by negative 2. We expect the remainder to be 0. Remember the remainder theorem says, P of C equals the remainder of the division by C. Okay, so don't forget that. So drop the 1. Negative 2 times 1 is negative 2. Add these two values. That's negative 6. Negative 2 times negative 6 is 12, plus negative 1 is 1. And it was, something is wrong. That's not right. So let's go back. I think I must have, so it's not negative 2, it's negative 3 and 2. Okay, so I was wrong. So we're going to do 2 here, sorry. So drop the 1. 2 times 1 is 2. That's negative 2. When you add negative 4 plus 2, 2 times negative 2 is negative 4. That's negative 15. 2 times that, now that makes sense because the remainder is 0. And note the quotient. So this is remainder. And quotient, that's constant. That's x. And that's x squared. This is quotient. Okay. So the factor theorem says, since 2 is a 0, 2 is a 0 of p of x. The factor theorem says x minus 2 is a factor of p of x. Where is the other factor? Right there. So now we're factoring this. So we reduce the third degree polynomial into a linear times quadratic. Now, since it's quadratic, repeat step 3 until your quotient is quadratic. Well, we don't have to repeat it because the quotient is quadratic, or it factors easily. It's both actually in this case. It's quadratic and it factors. This is x minus 5 times x plus 3. And looking for the zeros right there. We already know 1, and there's the second, and there's the third, and you can see all of them from the graph. I wasn't seeing all of them because my window was not. So I'm going to do zoom 6 just to see a standard go from negative 10 to 10. You can see negative 3, 2, and 5. Okay? Okay, so that was 24 from page 2-4. Now, let's look at the next example. Find all rational zeros of p of x equals 2x to the 4 minus x cubed minus 19x squared plus 9x plus 9. So first, remember the first step, we look for factors of possible rational zeros. P and Q. P is a factor of 9, 1, 3, and 9. Q are factors of 2, 1, and 2. So P over Q, we take all these, divide them by 1. Take all these, divide them by 2. And plus or minus, because a factor could also be negative. There's quite a lot to check using synthetic division. Thank goodness for technology. So we're going to graph it to see which one we should try first, just to make things easier. You know, back in my days, didn't even have any technology, so I did everything by hand. Minus x cubed minus 19x squared plus 9x. X squared. Okay, let me try this again. 2x to the 4 minus x cubed minus 19x squared plus 9x plus 9, and graph it. So it looks like negative 3 is a 0. Well, let's try, and maybe 1 is a 0. So let's try. Let's go to table. Is negative 3 a 0? Yeah. Is 1 a 0? Yeah. So we at least have 2 that we can see. So I'm going to take a note of that, negative 3 and 2. So then we're going to do synthetic division. Then we're going to do synthetic division. Wait. Negative 3 and 1, not 2, sorry. Yeah, negative 3 and 1. So then I'm going to divide, make sure this is in descending order, and if there's any missing exponent, you put a 0 for it. So 2, negative 1, negative 19, 9 and 9. Let's divide by negative 3. So drop the 2, negative 3 times 2 is negative 6. Add it, you get negative 7. Negative 3 times negative 7 is 21, plus negative 19 is 2. That's negative 6 plus 9 is 3, and that's negative 9. Remainder is 0. So that's your constant, x squared, x cubed. So negative 3 is a 0 of p of x. So x plus 3 is a factor, because it's x minus negative 3, and this is the quotient, which is the other factor, minus 7x squared 2x plus 3. Well, this is neither quadratic nor easily to factor, so we're going to do synthetic division again, because it says read. If that's not the case, we already tried negative 3, then we're going to try 1, 2, negative 7, 2, 3. Drop the 2, 1 times 2, 2, negative 5, 1 times negative 5, negative 5 plus 2, and that's negative 3, a remainder of 0. So that's constant, x squared. So since 1 is a 0, then x minus 1 is a factor, and there's the other factor. And it's quadratic, and it's factorable. So you get x minus 1, and that's 2x, and x minus 3 plus 1. Yep. So you have 1, 0, 2 zeros, and then this gives me negative 1/2 and 3. There's 4 zeros, and they're all rational. Okay, 4 zeros, and they are all rational. Now I have one that you need to try on your own on page 22 in the notes. Okay, it says above it, students, and there's if you, in case you don't have your notes, this is what you need to try on your own. The work is in the notes on page 22, so make sure you finish that. Now I want to do 48, page 284. 48, page 284. It says find all real zeros. Find all real zeros of p of x equals x to the 4 plus 2x cubed minus 2x squared minus 3x plus 2. So real meaning rational and irrational if possible. So again, first we start with the possible rational zeros. I want to see that on last. Make sure you follow my method. There's a lot of examples. No excuse for not following my method. P is a factor of 2. Q is a factor of 1. So P over Q, 1 over 1, 2 over 1. So plus or minus 1, plus or minus 2. And that's not, that's fine. Without a calculator, we can easily check all of them. But, we kind of get lazy. Now we can just put it in our calculator. X to the 4 plus 2x cubed minus 2x squared minus x plus 2. So from the calculator, it looks like, I don't know, it looks like negative 2 is a 0, or maybe not, I'm not sure, and 1. Well, let's see the table. Is negative 2 a 0? Yeah. Is 1 a 0? Yeah. It looks like negative 2 has an even multiplicity because it bounces off there. Okay. So negative 2 and 1. So let's start with by dividing by 1. It looks easier to work with. So 1, 2, x4, x cubed, x squared. Make sure you're not missing any exponent. If you are, then you put a 0. You drop the 1. 1 times 1 is 1. 2 plus 1 is 3. 1 times 3 is 3. That's 1. 1 plus negative 3 is negative 2. And the remainder is 0. Constant x, x squared, and x cubed. So 1 is a 0 of p of x. X minus 1 is a factor. And there's the other factor. Okay. Now we can try negative 2 on this to break it down more. So 1, 1, 3, 1, negative 2 divided by negative 2. That's negative 2 plus 3 is 1. Negative 2 plus 1 is negative 1, and that's a 0. So constant x, x squared. So let's break this down. So p of x equal, we got x minus 1 from the first one. This is negative 2 is a 0 of this. X plus 2 is a factor, and there's the other factor. Okay, now to find the rest. Well, this doesn't look like it's factorable. So we're gonna use the quadratic formula to find the zeros, the quadratic term. So x equals negative b plus or minus square root of b squared minus 4ac all over 2a. So a, b, c, negative 1 plus or minus square root of 1 square, 1, negative 1, 2 times 1. So negative 1 plus or minus square root of 5. So we have 4 zeros. The 1 we got from synthetic division, 1 and negative 2, and then negative 1 plus root 5 over 2, so root 5 over 2. So 2 real and 2, I'm sorry, 2 rational and 2 irrational. 2 rational and 2 irrational. Okay, I want to do one more. And, I'm giving you a lot of examples. Make sure you go over all of them. It's a good practice for the test. So p of x, again, find all real zeros, equals 8x to the 5th minus 14x to the 4 minus 22x cubed plus 57x squared minus 35x plus 6. Okay, so the possible rational zeros. P and Q. P is a factor of 6 and Q is a factor of 8. So we divide P over Q, all this by 1, all this by 2, 1/2, 2 over 2 is 1, 3 over 2, 6 over 2 is 3, we already have those. All this by 4, 1 over 4, 2 over 4 is 1/2, 2 over 2 is 1, 2 over 4 is 1/2, and then 2 over 8 is 1/4. We have all these. 6 over 1 is 6, 6 over 2 is 3, it's already there, that 3/2 is already there, 6 over 8 is 3 over 4, and plus or minus. So there's a lot of zeros to check if we didn't have our calculators. So here, let's type it in. So 8x to the 5th power minus 14x to the 4th power minus 22x to the 3rd power plus 57x squared minus 35x plus 6. Well, it looks like negative 2 and 1. Negative 2 has odd multiplicity and 1 looks like has an even multiplicity. Negative 2, 1. So 1 maybe appears more twice. Okay, so let's start with negative 2. 8, negative 14, negative 22, 57, negative 35, and 6. Nothing is missing. 5, 4, 3, 1, 0. Drop the 8. negative 2 times 8 is negative 16. Add them up. That's 60 plus negative 22 is 38. Negative 76 when you times these plus 57 is negative 19. That's 38, which is 3. Negative 6, of course, the remainder has to be 0. So that's constant x squared, x cubed, x to the 4. Negative 2 is a 0, so x plus 2 is a factor, and then this is the other factor. So you know we have a lot of work to do. Remember we said 1 looked like 1 has multiplicity of 2, so let's try it this time anyway. So divide by 1. Again, this is what we're reducing now. 8, negative 30, 38, negative 19, 3. Drop the 8. 1 times 8 is 8, negative 22. We get 16, 16, negative 3, and a remainder of 0 as expected. So constant x squared, x cubed. So p of x is, that's from the previous one. This 1 is a 0, x minus 1 is a factor, and that's the quotient. 8x cubed minus 22x squared plus 16x minus 3. Okay, so now we still have a third degree. It's not easily factorable, but it looked from the graph that it bounces off at 1. So maybe 1 is a 0 of multiplicity 2. So let's try 1 again. 8, negative 22, 16, negative 3. I'm trying it on this third degree. Drop 8. 1 times 8 is 8. That's negative 14. 1 times negative 14, that's a 2. Oh, it doesn't look right. Okay. So 1 is not a 0 of multiplicity 2. Okay. So if you look at, let's see, so calculus is messed up. Okay. So let's go back to the calculator and look. So I want to zoom in on that. So I'm going to do my window from say 0 to 5, and then see if I can see a better picture. Okay. So it doesn't look like, so it looks like it crosses at right before 1. Okay. Looks like it crosses right before 1. If you zoom in, right here. If you zoom in, hit enter. Here we go. So it crosses about 3/4 and then about 1. So let's check with the table. It looks like 3/4 or 2/3. 3 over 4. Here we go. Is it 2/3? It's not. Okay, so 3 over 4. So that's what we're going to do. And 3 over 4 is definitely here. Okay. So if we try 3 over 4 on the cubic, right here. So we're going to try 3 over 4 on the cubic. So we get 8, negative 22, 16, negative 3. Drop the 8. 8 times 3 over 4 is 6. That's negative 16, so negative 12. If you times these, you get 4. That's 3. Bingo. So then we write, so we bring this p of x down, x plus 2 and x minus 1 already there. 3 over 4, that means 4x minus 3. And then this is the quadratic, minus 16x plus 4. And we can solve the quadratic using the quadratic formula. And I got 1 plus or minus half root 2. So there's 5 zeros, 2 irrational, and 3 rational. Okay, 2 irrational. And that's it for 3.4. We'll do next 3.5 next.